welcome to a video on looking at section 5.7, which is on solving rational equations. So to begin with, we're going to discuss the difference between an expression and an equation. So an expression does not have an equal sign. The things that we can do with expressions, we can combine them, factor them, we can cancel things, we can multiply the top and the bottom by the same number, such as when you're trying to get each thing to have the common denominator. So expressions are things like 2 over x plus 5 plus negative 7 over 3x plus 15. There's no equal sign. You can add and subtract them by getting the common denominator, but you're not solving for x. If I suddenly put an equal sign over here and say this is equal to 12, I have now created a situation where we can find the value of x. This becomes an equation. So with an equation, other than it just having an equal sign, what we can do with equations, we can do everything we can do with an expression, but we can do much more. The big thing that we can do is we can perform operations to both sides of the equation, as long as we do the same thing to both sides. Okay? Both sides. We will use this to our advantage to solve rational equations. Okay, so the first thing we want to do is factor all of the denominators. Okay, that is going to help us find the lowest common denominator. Now, unlike a adding or subtracting rational expressions equation problem, we're not going to get everything to have the common denominator. We're going to multiply each side and everything on each side by the lowest common denominator. Okay, now when you're multiplying, we're not multiplying the top and the bottom like we did before. We are multiplying the numerator, or the numerators, only, the top. Okay? You're not actually going to multiply everything out. The whole goal is to have the denominators disappear. So factors, okay, of the LCD, the lowest common denominator, will cancel with the denominators. And when that happens, no more denominators. If they don't, then the LCD is wrong. You picked the wrong thing. It will happen. Okay? The denominators should be all gone. Well, actually, they have turned into ones, but we don't need to write those. Okay? Okay, after that, you are going to multiply what is left over in the numerators. Okay, then what should be left is an equation that should be fairly easy. It should be no more denominators, no more fractions, and you have to solve that equation that remains. It may be linear, or it may be quadratic. Okay? If it's linear, I hope I don't have to tell you how to solve a linear equation at this point. You isolate the variable, you get it alone, you solve for x. Okay? If it is quadratic, then we need to approach it as so quadratic, remember, is you have an x squared as your highest power. Then you're going to want to set it equal to 0 and use either factoring or quadratic formula. Usually my way of doing it is I check to see if it's factorable. If it's factorable, I'll solve it by factoring. If it's not, then I go and use quadratic formula. All right, and the final step that we're going to do here is you need to check your answers. if any of them make any denominator in the original problem equal to 0, then they are what are known as extraneous solutions. Okay, it's the process that we're using here can be tricky. It can introduce answers that are not answers, and so we just have to check to make sure they don't make the denominator 0. All right, so let's give some practice to try. Okay, so you can see these are all equations, and because they have an equal sign. Okay, so let's start with the simplest one here. X plus 3 plus x, or x over 3 plus x over 2 is equal to 10. So we start by finding the lowest common denominator. So I'm looking at my denominators. I have 3 and 2. My lowest common denominator is going to be 6. Remember, the lowest common denominator is the smallest thing that 3 and 2 will go into, and that is 6. So I'm going to multiply this by 6, and I'm going to put it over 1 to remind you I'm not multiplying the top and the bottom. I'm just multiplying the top. Multiply this by 6, and multiply this by 6. I don't really need to put the over 1 here because it's a whole number over there. Okay, so our goal here, what's going to happen is the 3 will cancel into the 6. So notice I didn't multiply the 6 times the x. I'm writing it, and then I'm canceling. So let's see, if I cancel, there's a 2 left. The 2 will go into the 6 here, and there'll be a 3 left. Nothing cancels over here. The next step was to multiply what remains. So what remains in the numerators. So I have a 2 times an x. Bring down the plus, and then over here I have a 3 times an x. There's nothing left in the denominators. I mean, there's 1's, but you don't need to write those. So 2x plus 3x is equal to 60. This is a linear equation because there are no x squareds. So I'm just going to solve it linear. I'm going to combine my like terms. I'm going to isolate the variables. So divide by 5. X is equal to 12. Okay, so there were no variables in the denominator in this case. So I'm not going to have any extraneous solutions, but we can check it anyway just to see that 12 divided by 3 plus 12 divided by 2 should equal 10. 12 divided by 3 is 4. 12 divided by 2 is 6. And yes, 4 plus 6 is equal to 10. It checks out. All right, let's try number 2. Okay, this one is obviously more complicated. We have denominators that we need to factor in order to figure out what the lowest common denominator is. So let's go ahead and start here. We have a GCF of 2, so we have 2 times x plus 1. This is a difference of squares, so we're going to do x plus 1 times x minus 1. And then this is just x minus 1. So if you remember for the common denominator thing, the idea of making it fair. Okay, this has an x plus 1. So does this one. So we're going to need one of those. We're going to need an x plus 1. Okay, this has an x minus 1. This has an x minus 1. So we're going to need one of those. And then the other thing that I see here is a 2. We're going to need one of those. Okay, so these are the 3 pieces. These are the 3 things I'm going to multiply to everything, and that should make all my denominators cancel. Okay, all right, so at the top, 2 times x plus 1 times x minus 1. Remember, this is on the top, over 1. Let's just squeeze it in. It's not going to fit real well. Okay, let's do some canceling. All right, in terms of canceling, we've got 2's gone, x plus 1's gone. X plus 1, x minus 1 are gone. X minus 1 is gone. Okay, going to erase this so I can have some more room here. Okay, so what do I have left? There's no denominators. They all canceled. On the numerator, I have 1 times x minus 1, which is just x minus 1. Bring the plus down. Next, I have a 2 times a 5. That's just 10. Now the equals. Okay, I've got a 2 and an x plus 1. Okay, that's 2x plus 2. So again, I have a linear. Okay, so I'm going to combine like terms. Move the x over. Subtract 2 from both sides. X is 7. Okay, so the 7, if I plug it in, if I put 7 plus 1 here, I'm not going to get 0. 7 minus 1 is not 0. So I'm okay with no extraneous solutions. All right, number 3. Number 3 is a proportion. So we're going to do this one a little differently. What makes it a proportion is you have one fraction over one fraction, or equal to one fraction. There's no like plus 5, none of that stuff, okay? There's just one fraction equal to one fraction. And what you can do is cross multiply. So when you see a proportion, you could just cross multiply. So I'm going to multiply x minus 4 times 2. And then that's going to be equal to 3 times x minus 2. Okay, and then we just go from there and solve it. So that's 2x minus 8 equals 3x minus 6. This is linear again. Get x's on the same side. Negative 8 is equal to x minus 6. Add 6 to both sides. X is equal to negative 2. Okay. Next question, number 4. Solve for the given variable. Okay, so there's no numbers here. They're asking you to solve for a variable. They want us to solve, you see it right here after the semicolon, D0. We need to isolate D0. We need to get it alone. Okay, so I'm going to use the sort of strategies that we've learned about and get everything out of the denominator. Okay, so I'm going to multiply everything by the common denominator here. The common denominator is just one of each. There's an f, there's a di, and a d0. This is obviously a formula for something, and so we're going to use that formula, or we're not going to use the formula, we're going to rearrange the formula. So I'm going to multiply everything by f di d0. So instead of writing it 3 times, I'm just going to write it once with parentheses, and then I'm going to distribute. Okay? Here, f is going to cancel with di, or the f, and you're going to have di d0 times 1. Here, the di would cancel, and you're going to have an f and a d0. So on the other side of the equal sign, d0 and an f. Then I'm going to multiply this last one. I'm canceling it so many times I can't see what's left. Okay, so this time the d0 cancels, and I have plus f di. Okay, so now we don't have anything in the denominators anymore. And that's going to help us get these things together. So remember, we need d0 all by itself. So I'm going to move this term and subtract it from both sides. Okay, so I have di d0 is one term minus f, or d0f, it doesn't matter which way you write it, equals f di. Okay, so I'm now going to think of d0 as a GCF that I'm going to take out of those two things. So d0, and I'm going to be left with di minus f. Okay, and the last thing I got to do is I got to just divide both sides by this di minus f thing. So this goes away, and here's our answer. d0 equals f di over di minus f. Okay, so now let's look at a word problem. Okay, this is called a work problem. It says a fountain has two drainage valves. With the first valve open, the fountain drains completely in 4 hours. Okay, with the second valve open, the fountain drains completely in 5¼ hours. How many hours will the fountain take to drain with both valves open? Round your answer to the nearest. Okay, so think of it as sort of a rate. So we have the first valve. Let me zoom in a little bit. The first valve drains one fountain in 4 hours. Okay. The second valve would be one fountain in 5.25 hours. Okay. If we add those together, if they're working at the same time, take 1/4 plus 1 over 5.25, and we're going to say it equals one fountain in x hours. X is the amount of time it takes for them both. Make that better. Okay, so it's a rational equation. All right, so our common denominator is going to need a 4, a 5.25, and an x. So those have nothing to do with each other. So the easiest way to do this is just multiply everything by, actually I'm not going to use parentheses here. I'm going to multiply by 4 times 5.25 times x. 4 times 5.25 times x. You could use parentheses like I did in the last one, but I'm just going to write it out 3 times, okay? So then we cancel. The 4 cancels. So what's left is 5.25 times x. The 5.25 cancels. So we have 4x. The x cancels. So we have 4 times 5.25, which is 21. Okay, and then combining like terms, we get 9.25 x equals 21. Just divide both sides by 9.25, and we get that x is about 2.3 hours. We can round it to the nearest tenth. Okay, your problems you're going to do on your own. And when you come into class on Wednesday, I want to see your attempts at these problems, okay? And then we'll go over these. All right, that's it. The end.